Säl och välkommen till Reifimindar. Jag heter Lumarsunil och idag skulle vi halda åfram att gera lek. Alright, hello and welcome to my video. My name is Lumarsunil and today we're gonna continue to work on a game. So yeah, I just read that sentence in ancient or Old Norse. Well, the pronunciation might not be perfect and the words may not be like 100% accurate, but it was my best attempt at doing this. I've been studying a little bit on like the Old Norse language and some history around that, because I'm thinking that I want to incorporate like the old like Norse runes in the game and have that as a sort of secret language, or maybe not secret, but maybe you're gonna be able to read runes in the game and be able to like translate them and stuff like that. So I think I want to have that, and maybe even like if I'm gonna have like voice acting in the game, I would like the voice acting to be at least in like important parts. I want to have it in Old Norse, which I think would be kind of cool. So and that's why I've had that little intro there to give a taste of that. Okay, so let's get into this video now. So last time we did some last devlog for Kottefolket we did loading JSON tilemap stuff. So now we can load in tilemaps from the editor. Yeah, and in between, I've worked on the tilemap editor a bit. So I added functionality for layers. So now you can have different layers in the tilemap, and it will show like a foreground and background stuff that will be incorporated into the tilemap itself, and then you can just load that into the game, and it will render properly. And if you want to see me developing the tilemap layers, there's a couple of videos up for that as well. Then I did a bunch of other stuff, including under reader functionality and some other small improvements to the tilemap editor, which I have not recorded, but you might be able to see that in future videos. So for this time, we are going to work on the village area. We are going to create a tilemap for the village area. So this is going to be like the initial demo that I want to create to sort of flesh out the functionality and sort of trying to find the gameplay in the game. So I want to build this demo area, which is going to consist of a village and then at least maybe 2 other areas that's going to be like sort of adjacent to this village area, so that you can go out of the village and do some quests and stuff. Okay, and then since the village area is going to have ladders, I want to implement climbing ladders as well. And then I'm gonna add some random NPCs into the village as well to make it be a little bit more alive. Alright, so let's get started. Yeah, I'm gonna start to build the tilemap of the village area now. So yeah, I'll see you on the other side of that. Okay, so we're actually spawning in kind of a reasonable position here. I was kind of thinking like you spawn at the well or something like that, but I mean, yeah, never mind. Let's see if I can get my controller up and running. Oh! Look at this. It's actually lagging here. Interesting. So that's an optimization that we need to fix. Okay. Alright, we're back. And yeah, as you can see, I've made a bunch of changes to the stage. I made the background here. And so, yeah, I would consider this to be, yeah, somewhat complete now. Here's the mushroom, the big mushroom house. And yeah, all the different houses here. I edited the graphics a little bit on everything, basically. Made a little bit more detail and stuff, added some more decals and stuff, details around the village. But yeah, so now the next stage, yeah, so also as you can see, I've enabled like really fast to be able to move around fast and explore a little bit faster. Oh yeah, also we had a little bit issue of the collision boxes when drawing this many or generating this many tiles. So as if I enable the collision boxes here, you can see that I've actually made this merge algorithm that merges the tiles in a really simple way for now. I think this way we gain a lot because the tiles are often laid out in a horizontal manner like this. So this helped with the FPS a lot. So as you can see here, we have a lot of these, but yeah, at least they merged down to way less than we had before. So yeah, that's I can actually let me show you the code for that. So let's go to where the hell is that? Oh yeah, it's in initial scene and merge tiles. Yeah, so here where we I changed a little bit on how we actually initialize the level now. So I initialize the level before the physics system now because we want to set the level size here before we initialize the physics system. And why is that? Well, that's because we ran into actually two issues with the collision system. And one of them was that the boundary of the quad tree was set to just like the size of the background picture or something like that. And I mean, I guess that would be fine, but for now, but back when I didn't have the background picture that was covering the whole area, I actually had to change this so that the level size gets computed from before. So it gets computed from the tilemap JSON file. So we read in let's go back where we were here. In init level, we load the tilemap, so we get all the data that's required for the tilemap, and then we set the level size depending on the size of the tilemap now instead. So yeah, that's a bit more consistent with getting the actual level size. And then in the physics system, we use the level size to determine the boundary of the quad tree. So now the quad tree encompasses all of the things inside, so we don't get a whole bunch of stuff outside, because that really tanks down FPS, because everything that's outside of the quad tree boundaries are treated as brute force we're using brute force for those. So yeah, that really is very slow. So once everything is inside the boundary, then it's fine. Okay, so that's the change we did there. And then here we have level entities, and here is what we did before as well. So we go through the time map and we generate all the tiles, all like the ground entities. But if we go in here and we see where we actually do that, create ground from solid tiles. So same as before basically, but now we keep a track of where those solid tiles are in the grid. So we have an array list of vectors that we fill up with the solid, the positions of all the solid tiles, and then we just go through each grid position in the tile map, and we basically check if it's a solid tile. If it is, then we put it into the solid tiles array list. Otherwise, we don't. And here we just check: do we already have this position in? Because now when we have multiple layers, you might have one layer that has the position as solid and another one that doesn't, so we don't want to duplicate the tiles basically. And then here, yeah, this is where we just check, okay, is this, well, we go through each layer. Do we have a solid for this one? If we don't, then, well, wait, do we actually get multiple here? Because we're going through each layer. Yeah, we don't actually get multiple. We don't actually need this. What we could do instead is we continue. Once we've gone through every layer, if we didn't actually get here, so I think this is where you can use else. I'm not actually sure, but if you just continue through everything, and if you have an else, I don't want to risk it, so I'm gonna do this. So I'm gonna say found solid. Wait, no, what am I doing? Of course, when you get here, yes, when you get here, we just want to do continue. Why? So we skip. So that means that we're gonna skip all of the other layers. Actually, we could just do break here. Yeah, so we don't even need this. Okay, so we just break after we have done that, so we don't need to go through all the layers. Okay, that's a way easier way of handling that. Okay, anyway, so once we have all the solid tile positions in this array, we put that into this merge tile function, and we get back all the rectangles that you saw in the collision draw, like the when we draw the collision in, like, yeah. If I can just start up and show you. So here, if you see the cursor here, you can see all these rectangles that show up. They are the result of this merge tile function. Well, the positions and the size of those rectangles are because we get back. Well, you don't see it here, but we get back this ABB, which is a rectangle basically, and then we use those rectangles to create the ground that's needed. So we just calculate, you know, based on tile size and scale and stuff, everything, to get the correct position and the size of each tile. And how are we merging these tiles? Well, it's kind of simple. So basically what we do is we go through each of the solid tiles that we've found. Remember, we have a list now here of solid tiles that we want to merge. So in the case where a solid tile is adjacent horizontally to other tiles, and this is where I feel like it's probably better to show in a diagram or something, but let's say you have 3 tiles like this, and which are solid, and then you have a tile over here which is not solid, a tile over here which is not solid. So if we got all these in a list, and so let's say we're looking at the first one here. And what we want to do is we basically just want to look at left or right. Is there adjacent solid tiles? And we want to go as far as we can. And we're going to put all the resulting tiles that we found into this rectangle. So this whole thing becomes one rectangle. And if there's, we stop when there's no solid tile anymore. So if you go through the algorithm here, or the code here, so we basically go through each tile in the list of solid tiles. We check if the tile has already been processed into another rectangle, which I think might not be able to, well, yeah, it will be able to happen because we're not like removing tiles from the list while we're looping through it. And we have this check here to check, okay, have you already merged this tile here? So we're just checking we're checking all the rectangles that we have, and we're just checking is the position of this tile within this AABB here. So, but what we're doing is basically we're checking the top left of the min position of the rectangle, and to the bottom right the max position of the rectangle, and we're just checking if the tile position is within that. If it is, then we have already merged it and we can continue to the next tile. But if we encounter a tile that we have not merged yet, then we find the adjacent tiles. We find the number of adjacent tiles. This is a number, so it can either be 0 or some positive integer, and we find the adjacent tiles to the left and to the right. And once we've done that, we can create this rectangle by just like subtracting the left and adding the right to the top left and bottom right positions of this rectangle. Okay, so that's easy enough. And then how to find the adjacent tiles? Well, we basically go through each tile in the set, the list of solid tiles, and we just check, okay, or do you exist at this position, at the desired position. So let's say we're finding adjacent tiles to the left, then we simply we take a step in that direction by taking our needle here is the position of the current tile that we're looking at, like in that we're trying to merge with other tiles. And then we take one step in the direction that we've provided. For left it's -1 0, and for right it's 1 0. And then we get the next position here, and then we simply go through each tile and just check, okay, does it exist here? And if it exists, then we increase the number of adjacent tiles found by 1. And then we also call this recursively here. And I did it like this to make it more simple. I couldn't find a simple way to do it imperatively, so I did it recursively here. There might be a million different ways of doing this, but this is how I did it right now. Okay, and then and it works. So there we go. So then we return the number of adjacent tiles in the given direction. And so we do that for both left and for right. And then we build this rectangle, as we said. And then we simply return this list here. So, so if we go here, so now we have this list of AABBs, which we don't see in the type there, but we see it here. So we get this list of AABBs, which is rectangles, and we free it up at the end. We go through each tile, each rectangle, that's the merged tile, and then we just do some scaling and translation based on, well, not translation, I guess, but we do, well, yeah, we do translation as well, but we do some scaling and translations to get the position and the size of the rectangle at the right position for the physics world. and then we just create this ground entity at this position with this size. And that's what you end up seeing in this function we've had from before, which just basically creates a new entity with a physics rigid body there. Okay, so that's basically the merging algorithm that I implemented. So it's very basic. It doesn't really go all out on the merging stuff. I mean, I guess you could do a bit more to make it really super optimized, but I made it halfway, and it was satisfying. It satisfied the needs that I had, so I'm gonna stop there and continue. So yeah, that was that. And next up, I'm thinking about you see all these ladders that I've placed around, but you can't climb them yet. So I'm thinking I want to implement those, but there's a slight problem though with that, and it's that there is this collision here, and the collision is because we have a tile over up there that's blocking, and we want to have that because if you're gonna stand up here, I want it to block. But if you crouch, let's say you push down to climb down the ladder, then you don't want it to. You want the player to be able to climb like inside a wall. I guess that could be like one solution maybe, because I'm thinking about how will I solve this problem. And yeah, one way I guess is to disable the collision for the player temporarily while actually climbing. So that could be one thing, like disabling the solidness, I guess, of the player while climbing. Yeah, that could be a thing. So you could have the player enter like a special state that's climbing, and while you're climbing, you're not solid anymore against the ground here. And you can just move up and down, I guess. And I want to have that you can like jump in the mid-air or something like that. So yeah, I think that should probably be what we're gonna do there. All right, so let's go ahead and sketch that out. So yeah, we're gonna work on climbing ladders, and also I want to restore the jump factor here. There. Okay, so how would we do this? So I think let's just do this in a very simple way. So let's just add a new player state. And this would be climbing. And I don't actually have, or climb, I guess. I don't actually have a graphics for this, but we'll just do with I'll just make some weird animation and we'll just use that for now. But this one, does it need to have any other like state to it? I don't think so. I think it's just like a boolean, like if you're climbing or you're not climbing. So it doesn't need any underlying state or anything. Okay, and now we should get a whole bunch of errors here because we need to add some cases. And this feature is really nice. Okay, so where are we now? We are in let's see, it was some time since I was in here, so I need to get my bearings a bit. So we're basically updating the player, and probably maybe we want to put this in a method that can assess what we're doing here. But we are checking for each state, and what we're doing is we're checking the attack state and setting another state if the attack is up. Right, so this is where we check for timings in the state. So We don't have that for climb, so we're just gonna do that. Okay. And then we'll check here, and this is the animation, so we can just copy something else here, and we'll do climb there, and I'll just add a climb animation, but we don't have that yet, but we can just add it like that. Actually, you know what? Let's just do walk maybe. Yeah, let's just do walk here so that we can actually see like moving around. Okay, so right, so now we actually have a new state, but we don't have anywhere where we actually enter this state. So when are we going to enter the state? Well, probably when we're standing close enough to a ladder and then we press up or down, I think. Yeah. Well, first off, we need to define where are the ladders. I guess we could do that with just checking like the tiles. So if we go to our tile map, so here we have get is solid. We could also have just this is very temporary because this is gonna be determined by entities. Like I'm gonna do this in another way later, like add this as an actual feature in the editor to be able to define this by the map instead. But for now, this should be an easy way to do this as well. So let's just do get is ladder, and then we basically want to do the same thing we're doing up here, and so here we're checking, okay, what's our like tile source? Is it nothing? Then it's just empty space, so it's not a ladder. Otherwise, we get the position of the tile in the tile set, and I'm just gonna check where that tile is. It's in, so ladder top left is going to be x0 and 0, 1, 2, 3, 4, and then ladder bottom right is gonna be, so this is like the top left where in the tile set where this is. 4, 5, 6, 7, so 0, 7. So between these like tiles in the tile set, that's where this where the ladder tiles are. So we're basically we just want to check. We're gonna reduce and because we're gonna use a vector vector comparison here. So we need everything to be correct. So what we need to do is we need to check if P is more than or equal to ladder top left, and then we need to copy this. It also needs to be less than or equal to bottom right. So now it's within the min and max. Okay, and that's now we know when the tile is a ladder. Right, so now I want to create entities basically. Actually, you know what? Maybe I'll just create the component and stuff right now. Yeah, I can probably do that right now. So let's create a ladder. So this would be a ladder component. What does a ladder component have? I guess it doesn't really have anything. I guess it's just like, you know, I'm a ladder. It's basically a tag. I just need to scan through here and see where we should fit this in here. Right, so we have these is duck input on and stuff. So let's add this as is. I mean, I guess we have duck and what else do we have? Do we have up? I don't think we have anything that's like up. So I would think that is climb input on, and that would simply check Let's have climb that's on here, like a separate thing. There. And then I think that it's either gonna be greater than or less than. So, because it could be, so this checks for positive, which I guess is down. But it's also, or if y is less than climb, then minus climb that's on. Yeah, that's the climb input. Then I want to check, so here's the combo thing. So we probably want to do it down here, like instead of, like, it's gonna take precedence over ducking, I guess. So let's do it here. Let's do is climb input on. So now in here, so we could still have an acceleration going on here. So we have the acceleration. Where's that? It's here. So it starts at 0. And we're doing stuff here. So let's do intends to move through. I get this would only be enabled once we have or are actually on a ladder, but let's do this first. So let's try like the action of climbing first and see how that works. So I just want to set the state to climb, basically, and I guess we can set this depending on the direction that we want to climb. So let's make some more functions. There is climb up input on, then we do this, is climb down input on, then we do this. Okay, so then here we check, well, I guess we just need to check one of them. So is climb up input on, then the y acceleration will be set to -1, otherwise 1, I guess. So let's try that. Let's also do, while we're climbing, we cannot move normally. We can move. I guess we could just keep it like this. But if we're climbing, I think we want to have a, like, if the state is climb, we want to have a special case here. So we want to say if player component state is equal to climb, or the climb input is on. Yeah, I think we want to do this, and then this part is in an if here. If this is true, then we just do that. And wait, but it might not actually be climb either. So we want to check if the input is on also. So it's either you are already in climb state or you're trying to climb. Then we are kind of locked into this mode. And we check here, we set this. I mean, I guess you could also do this. Climb down, input on, else 0. Okay. And we set the state to climb, but it's already climbed, so yeah, if player's component state not equal to climb, then we set it to climb. Okay, And what we also want to do is once we've done that, then we need the player body and we need to say player body s is static equal to true. And I think we want to have here a player component state is not equal to climb. Then we want to set static to false. Okay. So if we're not climbing, then we're not static. If we are climbing, we set us to static. And we can move up and down. And then to exit the state, you can press the combo button, I guess. But we want to have also that you can exit the state once you want to like jump off the ladder. So you can do this jump, but you can't do that if you're climbing. Well, you can do that if you're climbing, I guess. If you're on the ground or you're climbing. Then we do that. And also, if we are climbing and we do this, then we also want to exit the climb state. So we can do, actually, let's put this over here. And let's say player component state or set state. So if player component state is equal to climb, then we want to set this to whatever, idle, I guess, maybe. Well, I guess it depends on if you want to. Yeah, it's gonna be idle for one frame and then set to something else next frame. And then we can check, okay, is the state not equal to climb? After all that, yeah, we do static equals false. Okay. So now we can jump to exit that. I think we can try it and see how it looks. I can move as normal when I press up. Okay, so gravity is still affecting us. Right, because we don't have a dynamic way of changing staticness. So when we set static to true, we don't actually do anything. Okay. Well, we do one thing. We disable the collision detection, so by other static things. So I guess that's one thing. That's actually, and then I can jump to exit the ladder state. So if we imagine now that this is a ladder, we can climb up it, and we can jump to exit the state. What if we exit like inside this ground here, with and exits like that? Okay. Why? Okay, so a couple of things. The acceleration, probably not a good idea for this type of movement. Also, the gravity still affects us. So what I want to do is I want to hack this a little bit. So I want to set the instead of being able to disable the gravity for one thing only in the physics system, we are actually gonna set this to static, but we also want PA to be negated. Like anytime you are climbing, you want the gravity to not affect you. So So in here we want to set set y to be -1, 1, else 0, and we also don't want. Well, I guess it's not going to be PA. It's going to be PV because it's going to be a constant velocity and not an acceleration type thing, I think. All right. So anyway, maybe we'll add PV here as well, that you can change. And I think instead of setting PA here, we're gonna set PV, and then we also want to set Y on PA to be negative gravity. So I'm not sure. I'm just gonna look up where we can get that. Okay, so apparently we actually set gravity when we create a physics system, so it should be in here. There, and the gravity. Wait. Oh, here we go. Gravity equals physics.gravity.earth times pixels per meter. So this is the actual gravity that we're using. So I guess we can just take this this one and use that. So PA, I think we're gonna set X to X of physics system dot gravity and set Y to Y. Okay. I mean, I guess we could also just say this is equal to negative physics system dot gravity. I think we can do that. Also, we need to get the physics system as well. So physics system like that. Okay. So now the gravity should be negated once we enter that state. So we can test that by just doing it in midair. Whoa. Okay. Let's see. Right, we are okay. So we are doing this thing here. Okay. So right. I think we just do an apply force then. Yeah. Actually, it's not a force. It's actually we need to modify the. Yeah. So we need to modify the gravity directly here. So we can use V set P this, and then the P is going to be negative physics system dot gravity. There. So this basically, because this this vector is a vector that has components that are pointers into the physics system. So set P will simply set these two to whatever's in here. So that way we can set the acceleration directly with that. So that should, and we basically, this also overrides anything else that we've done. So but that should be fine. So let's try that now. Still not doing anything with PV, so we should be fine by that. And you can see here that oh I see. So one I need to reset the velocity as well. So I need to do velocity is going to be 0. Let's try that now. There we go. So now we actually sort of almost climbing. We just need to be able to climb up and down now. So this PV here, we need to make sure that this actually does something. So what we're gonna do is we are going to say, all right, so we have two functions here. We have apply force, but we also have apply impulse. And I'm not sure if this is like the correct mathematical way of doing it, but or if in this version that I have implemented in apply impulse is like mathematically correct, but I'm just gonna use it and see what happens. So we're just gonna do the velocity like this, and I think, yeah, we do need some sort of like player, like climb speed or something like this. And let's just define this to be, I don't know, 10 something. And then, oh yeah, it's gonna be a scalar. Okay. So now let's see if we can actually move up and down while we're climbing. I'm not sure if anything is happening, so let's add a couple of zeros. Okay, so we are moving. So let's add a couple of more zeros, I guess. Maybe that was too much, we'll see. It's all right. Okay, so let's cut this by half, or yeah, by half. Should be linear, right? I mean, that feels kind of good. Yeah, we can start there and adjust it as we go. But yeah, that's actually, let's increase it by a little tiny bit, and then we'll call that a day. So cool. Now we have that. So what we need to do now is we need to check, okay, can we actually enter this? Well, there's two things left, I think. Well, maybe more than two, but yeah, actually three that I can think of now. So one is we need, once you've, yeah, first of all, we need to create these ladder entities. Second of all, we need to have like, are we close enough to a ladder to actually start being able to climb? Third of all, we need to check, okay, once we've reached the end of the ladder, we need to exit the climb state, either at the top or the bottom. So we need to check that as well. Yeah, so first off, we're gonna create these ladder entities in our initial scene. When we create the level, this one. So what we want to do, so we create the solid tiles, but we also want to create the ladders as well. So create ladders. And it's actually kind of good that we have this merging thing here, because we can reuse some functionality of that to actually make one ladder entity now. So I think we want to basically do the same thing here. We basically want to fetch all of the tiles that match the criteria. I think what we do is, let's do get tiles, or query tiles, I guess, maybe. Query tiles, and we have a tilemap, and then we have the query, and the tile query is a union. This is just very on the top of my head right now. So I want to have solid, or I want to have ladder, because these are like in functions in the tile. So that's why type. Oh no, it's an enum, not a union. Okay, so solid ladder. Okay, and now this would return a list of tiles, I think. Or vectors, maybe even. Yeah, vectors. Okay, so we basically do all this. We check if, so here we check if query, so we do a switch on the query, and we're checking is it solid. Then we do this, is it ladder. Then we do this. I mean, actually, it's probably better to wait. Where are we? It's probably better to get the tile first. So layer get tile, and then check on tile here. Tile get is solid. Get is ladder. Okay. This is the result. We need the scene. Tile size scale we don't have. Okay. So why do we need this? We don't need this here. Okay. I guess we'll put it there. Right. So solid tiles. It's gonna be equal query tiles. Oh yeah, scene.query tiles. And this is gonna be the tilemap. And this is gonna be solid. Okay, so now we get the solid tiles. And we also need to now defer 3 solid tiles instead there. And we don't deinitialize here, we actually return results to own slice instead. And then, yeah. And if, so either we have solid or ladder, yeah, this should actually be enough for that. So let's just check if this works still. What's happening here? Try, okay, catch on reachable. No member named items. Oh, yeah, so I just need to do that. Let's actually do init, what's it called? Level tilemap ground. This would be the ground. And tilemap. And we need time size scaled. There. All right. And now we don't need this. We can just say init, well, scene, init level, timelapse ground. And oh, I can say solid. Right. Okay. And then we also do the other one. So we'll take this. We will say init level timelapse solid. Oh, this is ladders. And we'll do the same thing, but this is now the ladder tiles. Oops. Right. And this is now ladder. And then we want to merge them, but we also want to modify this a little bit then. So we want to merge them either horizontal or vertical. So let's do the same thing here. Let's do merge type. is an enum. So horizontal or vertical. And we do merge type. Okay. And then we check here. So here we do left or right. So this is basically if actually we could call this min and max, I guess, instead. So min, max. Okay, this should stay the same. And then, but this is different then. So if if merge type is equal to horizontal, then this is going to be 1, 0. So basically only x 1. Else it's going to be only y 1. That's the step that we want to take. Then min is going to be step. It's going to be negative step, and this is going to be positive step. Yeah, that makes sense. Okay, so that should do the same thing now, and we can decide the way that we are, the direction that we're doing this. So this for solid should be horizontal, and for ladders, it's kind of cool that it worked out like this here. So we had this. It was lucky that this aligned so well here. Well, I guess we'll see if this works well. But so we got this merged tiles now. So these are the merged ladders now. And we can do the same thing here. So this should all be the same. And then instead of calling it ground generic, we want to initialize a ladder init ladder entity. So we have the position and we have the size. Okay. So we do want to do this as well. And we do want to have a radio body because we want to check for distance and stuff like that. Well, yeah, we want to check. Well, we basically want to check against the position. And so density doesn't matter because this is not gonna be solid. Okay, and then the shape. Yeah, that should all be the same. But the one difference then is that we do scene registry, and then we add a ladder component, and then we go to our ladder, and we do just make, for convenience, we're just gonna make this function here. Okay, and down here we need to add this component as well. So ladder component there. Okay, so now we have the entities, hopefully. I wonder if they show up now. No. Okay, so we need to, do we call this function? I mean, I would be surprised if we don't run into any errors, although we are using reusable functions here, but yeah, I mean, oh yeah, so we don't call it here, but we can just do this now. So okay, interesting. Okay, so you can see here that we actually get our ladders. but something weird has happened. Also, they seem to be solid as well, so interesting here. So we are getting the ladders. We are merging vertically. Oh, we are initializing them as ground, although they were not actually produced correctly either. So let me just check here. So find adjacent files or tiles. I mean, this just has a generic direction, so it should not matter if it's horizontal or maximum. Oh, I see. I missed this part. So we have min, which is just a use size, right? So we actually probably want to, so min v is going to be step times min, right? And then negative is going to be negative. And then max v is going to be step times the max. And then instead of doing init here, we do min v and max v. No, but this is not negative then. But this is, okay. So we'll do that maybe. Yeah, because that was a scalar before, so now it's not. It's like min is how many steps do you take in that direction. So it's always going to be positive or 0. And yeah, this should probably work. Because we still want to from, I'm just going to do float from int here. Because we still want this generation of the size of the ladders should still work. There you go. So now we got this ladder here, and it's solid because we are still calling. Let's see if we can go back here. So yeah, we're still calling init ground, so we should call init ladder. Oh, we need to return this, of course. Expected type expression. What? What? What am I missing here? Type expression? What if we do this? No? Yeah. So we need to return this, right? Okay. Yeah, I get this weird error sometimes. I don't know why. But I don't think that's an actual error. I think that's just the LSP bugging out. Okay, there we go. And we do this, and we can see we got the entities, and yeah, so we have the actual entity now in the correct place. So great. Yeah, so we have we want to snap to the ladder. No, but we want to check first, like, okay, what ladder is within this distance? Do we have an entity within this distance? That's a ladder. So we want to query for that when we climb, and we're not already climbing. So before we actually get to the point where we're starting to climb, let's see, player. Wait, no. Handle input. So, right here. So if we are not yet climbing, and this is the first frame that we are starting to climb, then we want to make sure that we can actually start the climb. So let's put this up. Let's move this up here. Yes. But if we're not climb, we also want to check then if, let's actually do a separate part here if you want to start climb. So let's check if the state is not equal to climb and is climb input on. Then we want to do some calculations and set state to climb if we want to do that. And then yeah, so we're gonna do this part here, and then we're gonna do this part here as well. Okay, and then this is basically gonna be this, yeah. But the climb input we don't need to check anymore. So this is the part where we want to enter. If we are not climbing and we want to start climbing, we want to check, do we have anything in the vicinity that we can climb? So we want to make a query to the physics system in order to get that those entities. So I forgot how to do it, but I know that we are doing it in the player system among other places. Let's just check where we are doing that. Here we go. So here we are grabbing the physics system, we are grabbing the intersectors or intersections from this hitbox. So we can do this basic thing here, and we already have the physics system, so we don't need to get that. The allocator we have as well, so we can do this, and then we get the intersections. So we need a hitbox, so we need to create a hitbox that we want to check for. And I think what we want to do is we basically just want to get, it's basically just a player hitbox, right? If the player hitbox is on a ladder, you get to climb that ladder. And then I think we're gonna determine based on distance somehow. But let's do player body and then ABB. And I think that the ABB is updated to the position as well. But we'll see. Okay, so now we want to see this. Is this a ladder component now? So maybe ladder. And then if we have a ladder, I guess we can do this. Okay. Then, yeah, if we have a ladder, then we want to set, we want to basically keep track of which one is like the smallest distance, I guess. Well, actually, you know what? Let's not do that. Let's actually do a very naive approach, and once we've found a ladder, we break out and we receive this ladder. So we're gonna get a ladder here, and this one is gonna be ladder. No, what? I can't do that. Do it now, or like this. Ah, there we go. And then we break ladder, and then we do. We don't need a ladder component. we just need to know that it has that, and then we can return the, I guess, the entity or the intersection, or yeah, let's return the intersection. So this is the ladder intersection, and right. So, but if we don't find it, we continue. And then if we don't find anything, I guess it's going to be a null. So this is like a nullable intersection. Let's actually get the body instead. I think we have like the entry. Yeah, this is a rigid body. There we go. So we got the nullable rigid body. And what we're gonna do then is, yeah, we're setting the velocity to 0. We should also set the position then to be so that we want the X center of the player to align with the X center of the ladder. So we want to do player body, and the position, which I believe is PX, is going to be, well, this is going to be the center. I think that actually is the center. So that's going to be the same X that the ladder has. So this is going to be the ladder PX. Okay. Now this should only happen one time as well. Let's see, expected type, rigid body flat, found, wait, expected nullable. Oh, okay, found, okay, so this is a, hello, this is me from post editing. I lost audio to this part of the video. So yeah, I'm gonna have to narrate this in post here. Alright, so we were implementing the ladders things here. Yeah, so I'm struggling a bit here with this, and yeah, I just decided to cheat a little bit and use direct access to the members or the components here in the vector by doing that array access instead. So yeah, and then there's a nullable, or wait, oh yeah, the ladder is nullable here. So then you can add a dot question mark to access the underlying, to unwrap that basically. And we're checking if ladder is null. Yeah, deciding to use an if here instead, which makes this nested, more nested, but yeah, that's just something that happens in Zig often. I realized that, and that's something that usually in other programming language you want to avoid nesting as much as possible, but here you just have to live with it a little bit because of how the language is designed, and I don't really mind it that much, because I mean you still have the same like sort of complexity. It's just more annoying to actually look at, I guess. I mean, it's a nice feature to have sometimes, but I would really like to have like maybe the inference of, if you check if it's null and then you return if it's null, then you get like inference that, oh, it's you know that it's actually not null after that point. So kind of like TypeScript has that, but then again, then that refers to the actual variable itself, and you don't have to unwrap to actually access the value underneath the null. So it's not wrapped in like an optional, it's just the value itself. Right, so let's see what we're doing here. So yeah. So this part was kind of tricky. Registry. So this is the ECS registry system, and we're using try-get to, because we don't know if the entity has the component that we're looking for, the ladder component, or not. And so the issue here was that it complains that try-get doesn't exist on this, which has worked from before. So it does exist on the registry itself, but then the registry tries to access try-get from like it has like an internal storage container for that component. And it says that, oh, I can't find this function, because the reason is because that when you register a component, or when you try to use a component with the ECS system, it checks like the type of the component that you're trying to use, and if that component doesn't have anything in it, like if it's just an empty struct like the ladder component is, it doesn't have any fields or anything in it, and then that component, because ECS uses comp time to actually check for that, they decide to, okay, so there's nothing in this component, so then you basically get this container that has nothing in it almost. It just has a sort function. Now I wasn't sure how to use that, so I just decided to actually add something into the I just added something into the try-get, or something into the ladder component to have it there. So to have it like work with the usual functionality, so that you can use try-get, because I needed to use that. And here you can see the if statement that actually is, if is empty struct, then you get this container which only has sort. So I'm not sure how to use this really, but yeah, it was an easy fix. Maybe there's some more idiomatic way to actually implement this if you have an empty struct, but I'm not sure how that would work. So here you can see that I just decided to add something into the ladder component here. So I just decided to just run random enabled, that we don't really look at to do anything, and it's not gonna do anything. It's just to make the ECS registry happy here. Yeah, and there we go. Now we're running the game, and we're trying to get this ladder working. As you can see, whoa, it kind of flew out there. Yeah, so there's a bug with the actual velocity of the ladder climbing. Yeah, and as you can see, this code now makes it so that you can find a ladder to latch onto. So when you're climbing, you can only climb like up and down if you're near a ladder. And here we are. I'm trying to figure out like how to solve this issue now. And the issue was that the velocity kind of stacks up with the impulses that you put there. So we're resetting the velocity every frame now, where if you're climbing, so we're resetting the velocity because it's kind of special handling of the physics when you're actually climbing. So you get kind of locked on to the ladder. So there you see, now it works. Can still climb into the walls and stuff, but we're gonna fix that as well. So I was kind of surprised how easy, or it wasn't easy per se, I guess, but it went way smoother to actually implement the ladder system. But it's a bit like it feels a bit hacky, like the solution that I came up with. But I'm not sure how you would implement it otherwise. I mean, I guess everything is hacky when dealing with this stuff. I don't know. But yeah, I mean, what would not be hacky? Like implementing a real physics simulation of climbing a ladder. That's just not feasible, even though it sounds kind of cool. But yeah, so now, yeah, so I think next step is to latch onto the ladder. Or did we do that already? Maybe. Oh no, next is to actually, oh yeah, I think we are latching on, yeah, so we are latching on when we actually enter climbing mode. But the next step is to be able to stop the climbing at the bottom and top of the ladder. And I just realized here an issue, because as you can see, the ladder, as I'm showing here, the ladder top is actually the whole tile above this last part, or the last part is covering the whole tile. So what I decided to do is shrink the last tile, or the top tile, to only be 1 pixel height. That's kind of barely sticking up beneath or above the ground where it's at. So that way, when you check for collisions, you can only start climbing if you're actually standing on the ground. Well, or 1 pixel, I guess, on the ground, or yeah, at least it fixes this issue that I'm showing here, that you can start climbing like above the ladder. So you have to stand on the ground to be able to start climbing down. So that's what I'm fixing here. So I'm gonna shrink. The idea is that I'm gonna shrink that, and to be able to do that, I'm gonna go into init ladder and then shrink the size of the ladder. So what I'm gonna do here, so I'm gonna define a size that I want to shrink with, which I believe I'm gonna call like top cutoff. It says offset here, but I'm gonna rename that soon. And the offset, or the cutoff, is gonna be just the Y component, and it's gonna be the 1 tile size, and then well, yeah, 1 tile size and then -1, basically. So it's gonna be like 15 of the Y component. And then what you can do with that is you can say, yeah, you can use that to change the position, because we need to change the position and the height if we want to shrink it from the top. So if you can imagine, like the ladder is moving down as well as shrinking in height. So here we're defining the cutoff here, and I'm struggling a little bit with finding the exact formula here, but I think, yeah, just tile size scale and then -1 Y component here. So I think only Y1 here, yeah. And then I think you simply do, oh yeah, and yeah, and I think I'm gonna modify this as well to be, because this will create a bug, because X is supposed to be 0 here. But once you have the correct top cutoff, what you can do is just simply take away that from the height, and then you also add it to the position to get the correct rectangle that we want to have for the ladder. And as you can see here, I just realized that, oh, I'm not supposed to have any X here, so I'm modifying that real quick here. So I believe I'm gonna use v.init, I think. And that creates a vector with X. You supply X and Y components. So X is gonna be 0, and then Y is gonna be that. So it's basically gonna be 15 in the end. And now I'm gonna test this and see what the height will be, and there we go. Now the height has shrunk a bit from the bottom, but we need the height to shrink from the top, and then what you do is just add the same cutoff to the position to move the whole thing down. And we can see here when we test this, that, yeah, so now you can see that the rectangle has the correct size. Yeah. And then you can see that I'm trying to, while I'm going down, I'm holding the up or the climb button. And so it doesn't start climbing until we're at the absolute bottom of this, or the top of the ladder. Okay. So now I think the next step is to make sure, or make it so that once you reach the bottom or the top, we want to quit the climbing state. So we're going back to, I think, handle input. And I think, yeah, in here we're gonna check. So if we're in climbing state, we wanna check if we are intending to climb down or up by pressing the button. So if you're climbing down, I think that's the first case that we're looking at. So if you're climbing down, we want to exit the state if the bottom of the player body is the same as the bottom of the ladder, or same or more. So that way we know we've reached the bottom of the ladder. So then we want to quit climbing to not descend into the ground. So I think I need to grab the ladder. Oh yeah, so I ran into this issue as well. So we don't really have the ladder entity here. So what I do is I modify the climb state to hold the value, like the ID of the ladder that we're actually climbing. So we can easily get that information. Because when you start to climb, we know which ladder it is, so we can set that to the climb state. And once we want to quit the climbing, we can grab that same ladder, and we know that we know which ladder we want to check against. So here we're adding the ladder entity to the player state climb. And so now we need to modify where we create this climb state. So we need to add, okay, yeah, and here we actually try to get this as well. So here I'm gonna get the ladder body from the ladder. And I decided to get up here and check how we do it for player body. So we're just copying that. There we go. Now we have the, well, we need to change the entity that we want to get it from, which would be playerComponent.state.climb.ladder. So now we have that. Yeah, and here we need to set the new state as well. So we just use the ladder .key. So ladder is the rigid body, and we have .key, which is the entity, which we can use there. And now we have access to that over here. So yeah, now we should just look at the bottom of the ladder body. So player body, the bottom of the player body should be greater than or equal to the body of the ladder. There we go. Also notice here that the LSP doesn't really work. I'm not sure why, but I need to look into that as well, because it's a little bit annoying. It doesn't slow me down that much, but it's like, it's sometimes like finding this, like without having autocomplete, it's a bit annoying to like say, oh, what was that again? What? And I need to go and look it up. But yeah, most of the time it works. And there we go. Now we can start it, and you can see here that climbing up and down works, and it exits the climb on the down. So now we're gonna do the same thing for up, and basically the same thing here, except we want to check player body bottom is gonna be I guess less than or equal to the top of the ladder. And then I add 1. Not sure if the +1 was needed here, because the top is already +1 from the tile. I think I added it just to be sure that you don't end up in the ground or something like that, maybe. I'm not sure actually. But yeah, now we're testing it, and you can see here that it actually works now. So once you've reached the top, you exit the climbing mode. However, as you can see also, we get a little jump out when we reach the top, and I will try to disable that here. So don't remember exactly how I did it, but I think I just set the velocity to 0 once we exit that state. Yeah, I was contemplating here to have more of a general like exit climb state functionality, but I think I just ended up putting everything in these if statements, because we have one further down as well where we say if you're not equal to climb, then you are basically not in climb state. However, we don't have like edge detection on that. So, well, actually, maybe we actually do. I just realized we have the has state changed bool that we can look at. Okay, yeah, but never mind. I ended up implementing it like this, and it works. The only thing I mentioned it in the recording, or that I didn't record while I was programming this, that I'm realizing that this part of the code, like the handle input and even the initial scene itself, is becoming really spaghetti full with meatballs and stuff. So it's like yeah, it feels very large and annoying to deal with, but I don't really see any other way unless you like move things out, try to organize things better and move things out of the initial scene and into systems or something like that. But yeah, for now it's doable. I mean, I could get back into the code without much hassle, actually. So it might not be that big of a deal yet, though. As long as I'm continuing to work with the code and have it in my head, there shouldn't be that much of an issue. Okay, so here you can see I'm trying out the different ladders here. So yeah, climbing ladders now work, and yeah, I was surprised on how smooth it went. Well, it didn't went super smooth, but it went a lot smoother than I was anticipating. So yeah, I think the next step is to add some NPCs and add some dialogue to that. Okay, so I'm just gonna show you a little bug that I found while placing NPCs here. So as you can see, I'm placing NPCs with a controller. So I'm moving around and I can press a button to place NPCs, and as you can see, they are behind the background there. So I had to fix that bug, and I'm not gonna really show that because it's not really that interesting, but it's basically to do with how the layers are defined here. So I just realized that I'm using the old code for the layers. I needed to adapt that to the new system that we have. So I thought I was just gonna mention that. So let's get back to placing the NPCs here. Okay, I thought I was just gonna mention another bug that I found here, which is gonna be a fun thing to figure out. But basically, after I added enough NPCs, I got a segmentation fault. So that means there's some sort of memory error somewhere that I need to look into, and that's gonna be fun. But stay tuned for that. Okay, so as you can see here, I added a bunch of NPCs here, just removing the fractional coordinates here, because that caused like a jittering when moving around. So, but here you can see the NPCs are all standing around in different places where I've put them here. So basically what I did was I bound a button on the controller to actually add an NPC where I was going. So I went around different places and pressed the button to spawn an NPC. Then I logged out the position of the NPC when I spawned them, so I could just easily look up all the positions that I added NPCs, and so I could put them in a list like this and have all the coordinates and just call an init NPC with those coordinates. And so now the thing that's missing is putting some text in there. So I'll be right back here. Okay, so as you can see here, I put some of these. I didn't put everything in here, but and I realized here that there's an issue with the font. For one, the font looks kind of futuristic. I think it's the default font from Raylib, and so I want to change the font. So I thought that because I was using a font in Windows that could display these special characters. So you saw that I got for the special character on the O there, I actually got a question mark in. As you can see there, I get a question mark in the text. So I thought that I should just change the font and it should work, but that was not the case, as you can see later when I try to change the font. And the way you do that in Raylib is you basically need to save a font object somewhere and then pass that into the draw text function. So you have to load in the font, and given that this is going to be a game, it's probably going to be like bundled with the game so that everyone gets the same font. But for now I was just using like the font that I had, Windows. But I'll fast forward until we get to adding the font here. Okay, so I'm in the load function in initial scene, and as you can see, I'm gonna add an init font function, which is gonna add a font to the registry. So that's going to be how I decided to do this. So I simply added a singleton, I think, that's gonna be the font, so that you can get the font from anywhere and just use it if you want. So first off, you need to load the font from Raylib, and you just call load font, and then you pass the file name. And once you have the font loaded, you can use it. So I put it in a singleton, and yeah, you just put it in there, and then you can get it out by getting the font, like passing in get or passing in get the font type to the get function from singletons. Okay, and right now I'm trying to figure out how to draw the actual text, but yeah, I'm gonna end up just using Raylib for this. So as you can see here, I'm using like the draw text function in the draw system, but that one does a little bit of things like translating for screen to get like it paints the text in the center of where you put it, the thing. So yeah, I'm gonna fast forward until I'm showing the solution here. So yeah, as you can see here, we're using raylib.drawTextX, and that function allows you to specify a font, which we are getting from the singletons get that we've loaded from before. Then you have the text that you want to put, and it's gonna be a 0 sentinel, so I'm using a buffer here with 256 capacity, and I'm using buff_print_z from standard format module to actually use, or yeah, to actually print that with the 0 sentinel. And then and then we have the position, which is translated according to the screen, so that the offset, so that if you pass in 0, 0, that means in the middle of the screen. And then I use that position to draw the text. But as you're gonna see here, that will end up in the wrong position. And then you have the font size, and you have spacing, which I've put to 2 here. It's just an arbitrary number that I put there, and then the color. So let's see here how this looks. And as you can see, the font works. However, we still get the question mark, and the position is wrong. It's like in the middle of, well, not the screen, but the box. But it starts at that position. It should be, the center of the text should be at that position. So that's what I'm gonna fix here. Okay, so actually what I'm fixing here is not the position, but I'm fixing the question mark. So the thing is with fonts here is that when you load a font, Raylib loads in a default subset of that font into the program. So you actually, if you want to have the special characters, you have to specify which characters you want to load into the set. So here you can see me copying this special character and putting it into a string, which is called cold points, and that's the lingo used to specify what letters or symbols or code points, I guess, you want to load from the font. Because yeah, I guess there's a whole bunch of these symbols, so in a certain font, so you wouldn't need to load in everything unless, no, you wouldn't need to load in everything unless you would want to display everything at once. But even if you have a game that supports multiple languages, you load in that language that needs those characters. You load in those specific characters when you have that language. And as you can see here, I failed at this at first, so because I didn't understand how this worked. So this load code points function, you actually need to use the result of that and put that into load font. Well, actually not load font, but load font X. So as I'm gonna show here in a minute, I'm actually gonna use load font X instead, and then you can put in the code points that you want. So then you specify exactly which characters or symbols that you're gonna use from the font. Okay, so as you can see here, I've now decided to use load font X, and I'm trying to get the code points result as well. Doing some renaming here because of name clashes. And so load font X, you specify the file name of the font size, and which code points you want to load in. And as you can see, I'm only supplying the one weird character that you can see there. So this is the result of that. Everything becomes that character now. So yeah, I realized that, oh, I might need to actually specify all of the characters that I need to display from this font. So yeah, you need to specify like everything here. So I'm just gonna put in the alphabet, and yeah, and this is really nice because now I know how to load in like any random Unicode characters. So I can load in, for example, the runic alphabet as well, and use that to display different things. So yeah, that actually worked out really well. So so now I just add a bunch of, I've added the alphabet, uppercase, lowercase, and I add a bunch of like punctuation stuff. And this special character. So I'm probably gonna need more than that special character, but this is a start. And then when we test this, you can now see that it works. So yeah. Alright, so yes, and with that I'm gonna close this episode. So we've done a lot of things this episode. We have implemented, well, the first like demo village area, and a bunch of tiles and details and graphics with that, and placed a bunch of NPCs with their well, not everyone has dialogue, but I'm gonna add that, I think, in between next video. And we added the feature to climb ladders, which I'm happy with. So I just need to add a animation for that as well, but it works really well. So I'm glad with that. There's one pet peeve, or not pet peeve, but there's one small issue left there, and it's to do with how we make the player like solid or not solid now. Well, the player is solid, I guess, but it's not. It's we set the player to be static, which means that the player can basically go through other static objects, because static objects are not collision checked against each other. So that means the player can just go through everything when that happens. So and that's not really how I want it to work. I want the ladder to be more like, if you stand on top of a ladder, that kind of counts as a semi-solid ground. So if you approach it, depends on in which way you're approaching. So if you're approaching from the top, it's gonna behave like a solid. But if you start to climb down, it's not gonna behave as a solid anymore. You can climb through it. Or if you approach from the bottom by either climbing up or jumping up, it's not gonna behave as a solid. So I hope that makes sense. I mean, just think of how it works in other games, like any game that has ladders, basically, like Mega Man, or yeah, I don't know, any game, basically. So it's like, you know, the type of ground that you can stand on, and then you press down and you can jump down or whatever, and then you can also jump up to get to the next level. Okay, so but yeah, I think I'm gonna try. I'm not gonna do that particular thing in between, I don't think. But anyway, this is gonna be it for this time. So thank you very much for watching. And if you have any questions regarding game development, SIG programming, or programming in general, or this game project, then feel free to post down below, and I'll answer you if I can. Yeah, have a nice day, and I'll see you next time. Bye bye.